In this video, we're going to look at an example of 0 times infinity. So we've already seen 0 over 0. We've already seen infinity over infinity. In this video, we're going to look at this scenario here, where you have 0 times infinity. So find the limit as x tends to 0 from the positive side. And the reason for that is because of this. If you look at this block here, natural log looks like this. You see, natural log negative is well, the domain for natural log would be x being greater than 0. So anything on the right hand side, anything on the negative, it's meaningless. It's not even in the domain. So so we want to approach 0 from the right hand side. So we want to approach 0. So remember, 0 is here. So we want to approach 0 from the right hand side. So this is the one-sided limit. So we don't care what happens on the negative side. Okay. So here you've got one thing multiplying another thing, and as x tends to 0 from the positive hand side. So if you look at this here, quadratic. This here is a quadratic. It's heading towards 0 from the right hand side. So it's heading towards 0. It is heading towards 0. We don't care what happens over here because this is one-sided limit. So so this thing here is going to go to 0, and then this thing here, natural log of x, as x approaches 0, would be this. From the positive side, it will head towards negative infinity. It will head towards negative infinity. So here you've got 0 times. I know it's a negative, but when it comes to L'Hopital's rule, you can consider this as being 0 times infinity, even though it's so if you have negative infinity over infinity, you can consider this as infinity over infinity. Or if you have infinity over negative infinity, when it comes to L'Hopital's rule, you can consider this as being infinity. These two are pretty much the same when it comes to L'Hopital's rule. Okay, so here we've got a case where we have 0 times, yes, we've got 0 times negative infinity, but we can consider this as 0 times infinity. So here we've got a case, we've got this case here, 0 times infinity. So to work out the limits here, we would use this trick. We would you can always write a product as a quotient. So here you've got one block times another. Visualize this whole thing here as this, because this is just a trick we would use. Whenever you have 0 times infinity, we would turn this into a quotient. So we would turn the product into a quotient here. So so if you look at this here, here you've got this thing divided by this thing. You've got this thing divided by hang on. Start again. Sorry. Whenever you have a case where you have 0 times infinity, you can always turn a product into a quotient. So so you can always rewrite this thing as this thing, because if you look at this here, you've got natural log of x divided by, because that's this divided by this fraction here, 1 over x squared. Well, when you divide a fraction, you keep this the same, and then you times the reciprocal of this, so which will be x squared over 1, and this thing gets multiplied to the top, giving you x squared natural log of x over 1. Well, over 1 is just this thing here. So the point here is that this is exactly the same as this. So we can turn a 0 times infinity into a quotient. So rewrite this. It's nothing more than a trick. So rewrite this in this form here. So now if you look at this from the right hand side, this thing here is heading towards negative infinity. It's heading towards negative infinity. And then from the right hand side, this thing here is, well, x squared is going to be very, very small. But then when you have 1 divided by very, very small, the whole thing is going to be very, very big. So you've got this thing here. So here, when it comes to L'Hopital's rule, even though it's a negative infinity over infinity, this is of this form here. This is of this form here, infinity over infinity. So 0 times infinity, we turned it into infinity over infinity. Well, if you scroll back and have a look at this, hang on. So we've been given this, And remember, we've already seen this, and we've already seen infinity over infinity. So we've turned this into a form that we were familiar with. So we know this is acceptable. So infinity over infinity is acceptable. So you can apply L'Hopital's rule. So we've seen in the past that whenever you have this, we know for sure that we can apply L'Hopital's rule. Infinity over infinity, we know for sure that we can apply L'Hopital's rule. This one, we're not too sure, so we turned it into this form here. Once it's in this form, we know we can apply L'Hopital's rule. So now we can apply L'Hopital's rule here. So hang on. So we were trying to evaluate the limit of this, turn it into this. We know it's infinity over, yes, we can consider as infinity over infinity, even though it's that. But consider as infinity over infinity. So now we know, because it's infinity over infinity, we can apply L'Hopital's rule. So differentiate this, that will then give you this. Differentiate this, that will then give you this. So now from here, that will then take you to here. So here you could plug this in, but let's tidy this thing up first. Tidy this thing up first. So here you've got one block divided by another block. You could consider, differentiate this and then differentiate this, but let's just tidy this thing up first. So tidying it up, so you've got one block, so that's 1 over x, that's this block here, divide, that's this divide here, divided by this. So here you would times the reciprocal of this thing here, so that will then give you this, and then now it's top times top, bottom times bottom. That will then give you this. Now this is much cleaner. Rather than you looking at this, and try and differentiate it again or whatever, tidy up. This thing here will then become this. So now try and evaluate this now. As x tends towards 0 from the right hand side, this is going to be 0, and then from the right hand side, this thing here will be 0. So it's 0 over 0. So we can still apply L'Hopital's rule. So let's differentiate this again. That will then give us this. Differentiate this again. That will then give us this. So now this thing here is going to be 0. This is just a constant. So this is a perfectly legitimate answer. Nothing breaks down. It's not a case where you have 2 over 0. This thing here breaks down, but 0 over a number, it doesn't break down. So this is legit. So this is legitimate, and the answer happens to be 0. Okay. So if you get a graph plotter and plot x squared times natural log of x from the limit as you approach 0 from the right hand side, it is indeed heading towards 0, because here you've got a case where you've got this thing, and then natural log is this thing here. So you've got negative infinity here. You've got infinity here multiplying with something that's heading towards 0. In this case, it is this block that wins. The x squared wins over natural log. Okay.